Welcome to Homework Help for Chapter 6. We're going to start with question 3 from the practice homework. And it's asking, based on this table, how likely is it to have two customers enter the bank during any randomly selected hour? And all you really need to know for this one is that the relative frequencies are the probabilities. And so in this one, you just look it up, and it's 0.04. And that's what corresponds to two customers. Next question. Same table. Based on this table, how likely is it to have three or more customers enter the bank? Well, all you have to do here is look at the probabilities for three or more. That's 3, 4, or 5. I've recreated this table over in the spreadsheet so I can make it a little easier to do this. So I'm just going to go over here and say equals the probability for 3 plus the probability for 4 plus the probability for 5. And it gives me a probability of 0.88. Just adding them up. The next question is asking me for the expected value, which again, this is just a weighted average. So what I'm going to do here is I'm going to make a new column on my spreadsheet. And I'm going to take the first column, which is the number of customers, times the probability, which is the third column. And I'm just going to do that all the way down. And then I'm going to add them up. And this is going to give me my weighted average. So the answer for that is 3.54. That is the expected value, or the average number of customers who come in a particular time period. And on to question 6. And here we have a paragraph. I'll let you read that on your own, but the information I've pulled out of it that I put on my spreadsheet. The sample size is 100. The probability of a coffee bean being bad is 1%, or 0.01. And this question is asking, what is the probability that exactly 5 beans would be unfit? So I'm going to use the binomial distribution, because this is a binomial problem. And I'm going to enter 5 is the number of beans I'm looking for. Okay. And actually, let me just get an equals there. Binom.dist. 5 is the number that I'm looking for. The number of trials is 100. The probability of it being bad is 0.01. And I do not want cumulative, because cumulative would give me the probability of 5 or fewer. So I'm going to put false. And that's how I'm going to answer that one. And there's my answer. I'll round that to 4 decimal places before I enter it in. So I'm just going to come here, round it down to 4 decimal places. I get 0.0029, 0.0029. Jumping ahead to question 8, because question 7 was really the same as question 6, just different numbers. This time they're asking, what is the probability that 2 or fewer beans would be defective? So it's a binomial distribution. The number I'm looking for is 2. 2 or fewer, that includes 2, right? So the number of trials is still 100. The probability is still 0.01, but this time I want true because I want cumulative probability. So when I put true in this formula, that's going to give me the probability of 2 beans being unfit, 1 bean, or 0 beans. So anything that you put in the first slot here and you put true, it's going to give you that number equal to or less than. So I hit enter, and I'm just going to shrink this down to 4 decimal places. I get 0.9206. 0.9206. Okay. And on to question 9. This one is 3 or more beans. And so the thing with this is it doesn't do greater than. The binomial distribution doesn't do greater than. So how do I do greater than? Well, if I want 3 or more beans and I can't get those, what can I get? I can get 2 or fewer. And those 2 are the 2 possible outcomes, 2 or fewer and 3 or more. And the probability of each added together has to equal 1, because we're talking about probabilities. So what I'm going to do is look for 2 or fewer, which I already have, right, from the previous one, which is 0.9206. And all I have to do is equals 1 minus that. And if you think about it, this is the complement, right? The complement of 0.9206 is 0.0794. So that's the probability of it being greater than that. Now let's just take a look at this last question, question 10. Boyds took 2 samples of 100 beans. The first sample has 3 unfit beans. The second sample has 4 unfit beans. Well, the probability of any sample having 3 or more unfit beans, we already calculated in the previous question, is only around 8% probability. So if they've got 2 samples that are in there, that's highly unlikely. So I would have to say that it appears that the quality of the beans has declined, and their defect rate or their unfit beans is no longer 1%. It's actually higher. And so that's how we would interpret that. So what you want to do when you see these type of questions is think about how likely is this to happen, and it's usually based on one of your previous answers, or you could calculate it as well.